Let's take a look at classifying numbers based on their properties and what type of number they are into the various number sets. We'll start with every number you can think of. So if you just started to write down numbers randomly, they would fall into this group. These are all the numbers. Now there are a few numbers outside of here that you may have heard of before called the complex or imaginary numbers. Do not worry about them for right now. We will be sticking to this group of numbers called the real numbers. Now it's impossible to write down all of the real numbers, so I've just given a sampling of a few of them. You can see there's 0 in there, pi's in there, an unusual number. We have fractions, square root of 13 or the negative square root of 13. You'll see repeating decimals and even a non-repeating decimal. The 5.212112111 with increasingly more and more ones in between the twos. So this is all of the numbers that we can essentially think of. And it's not very organized. We get square root symbols in some cases and not in other cases. Some numbers are positive while others are negative. So what mathematicians do is they start to try and make sense of all of this. And so they break them into two separate groups. Here I've taken those same numbers, but I've kind of piled them up. On the left-hand side in blue are all the numbers that were listed that can be written as fractions. On the right-hand side are all the numbers that cannot be written as fractions. And these get specific names. On the left-hand side in blue, those are rational numbers. Rational meaning ratio. If you're rational, we can write you as a fraction. If you're not rational, meaning irrational, then we put you over in the red group. So it's a nice way to categorize or kind of start to get some sense of, all right, if we look at all the numbers, how can we group them? So these two together are kind of the first bases of how we try to organize all of the real numbers. Now keep in mind, every rational number is real, every irrational number is a real number. They're just now subdivided into two groups inside of those real numbers. So let's take a look at the rational numbers and see which numbers, other than, hey, you can be a fraction, what numbers can go in that group. And so if you look at all the numbers that we have, we can kind of see that if you're an integer, you are a fraction. Okay, 0 over 1 is still 0, but it's written as a fraction. 7 can be written as 7 over 1, which is a fraction, so it makes it rational. Any whole number like that. Now, other ones that are rational are fractions. So for example, 5/8, you can see it's written as a fraction, so it is rational. Finite decimals, 0.3, if you read it correctly, is 3/10. So you can write it as a fraction. Same thing with the negative 2 and 845 thousandths. You can write it as a fraction and simplify it. And then lastly, we have infinite repeating decimals. Infinite means it goes on forever. Repeating means you can put that over bar on the number and say, okay, now just repeat this 161616 over and over again. Those types of numbers can be written as fractions. It's a little bit tougher to do than just read it. You have to do a little bit of math to convert it, or you can use your calculator, which I will show you later on how to accomplish. So those are rational numbers, the blue hand side of all the real numbers. On the right hand side, we have the irrationals, and they're basically defined as any number that's not rational. Okay, numbers that require symbols are always going to be irrational. There's no way to write the number pi without rounding it. So to represent pi with all of its digits, we actually use just the pi symbol. It represents every single digit in pi. Square root of 53, if you were to type that to your calculator and get a decimal, that decimal would be similar to pi. It would go on and on forever. No place to ever put a repeating bar symbol. The other ones that are strange that are in the irrational numbers are these decimals. These decimals are infinite. They go on forever, but there's no place to ever put a repeating symbol. to say start over with this number or this group. You will notice patterns to them, so you could continue to write them all out by hand, but you can't abbreviate it and still have the same number. Now, the irrationals, if you're irrational, you're done. That's your group that you're in. But if you're rational, we can break you into smaller groups. So we go from real, you can go to the left side into rationals, numbers you can write as fractions. Inside that group that you can write as fractions, we have smaller sets. The first one is the integers. All the integers are rational, but they have a special characteristic to them. They're just all over the number 1 that we don't show. Inside the integers is a smaller group. That's called the whole numbers. The whole numbers get rid of all the negatives, and again are all these numbers that can be put over 1. So they're rational. And then lastly, our smallest group that we ever use is the natural numbers, or counting numbers, you'll hear them referred to sometimes as. And they just throw out the number 0, and they're 1, 2, 3, 4, etc. These are all subsets of the rational numbers. And let me show you what I mean by that. Let's take the number 2, for example. Number 2, if we start with the smallest number set that it's in, it is a natural number. But it is also considered a whole number. It's also considered an integer. It's also a rational number. And it's also a real number. So numbers that are natural also are in all of these other sets. Now, if we want the smallest set they're in, we'd say, well, the smallest set it's in is the natural numbers. So here is our final grouping for everything. Again, you can barely see it, but the brown box everything lays into, that represents our real numbers. Then you can be broken off into either the blue or the red, rational or irrational. If you're rational, you can be in one of these subgroups, integers, whole numbers, or natural numbers. And that's our entire number system of sets that we will be using. All right, and then lastly, we don't like to write out all these words, so we've created symbols for all of them. The real numbers, at the very, very top, the biggest set, is the capital R for real. It's got a double stem to it. It's not a typo or a strange font. I'll show you how to write those later. The fractions, or the rational numbers, we use a Q. That stands for quotient. The strange one here is Z. Z is used for integers. I've also seen the letter I used, but Z is more official, especially in higher mathematics for the integers. Whole numbers make sense with the W, and natural numbers use an N. And then finally, our irrationals. There's no really widely accepted symbol for the irrationals, so we generally write just R minus Q, which is all the real numbers, take away all the fraction numbers, and you're left with everything that's not a fraction, and that is the irrationals. So we just write R minus Q if we're just talking about that set. And that's it. Review this as you need to.